I'm here to talk about engineering at Facebook. A little bit of history about me. I moved from California to London to start our London engineering office last year. So I was based in California. I'm still a Californian employee, but I'm in London to start the engineering team there. And I manage the tools team. Think of us as the developer efficiency team. So my job is to make all the other engineers at Facebook more efficient. So we write tools, we take away process and things like that. And what I wanted to talk about was engineering culture. The culture word comes up a lot in my talk, and the way I think of it is, let me talk about it. So Facebook's engineering culture is key to scaling Facebook engineering. I was actually at South by Southwest in 2012, and I was on a panel on how to scale startups. And let me get a show of hands on how many people here work for a startup or a small company. Most of you, all right. The question asked to me was like, what do you think Facebook's hardest problem is? Like, what is it? And my answer was, it's scaling the engineering team. We have a need to grow really fast, but we also like to contain our growth because it's really hard for us to grow in the right direction, right? Like, it's easy to get bureaucratic, corporate, and things like that. It's hard to maintain culture. So culture is a very important thing. And that's kind of a theme throughout my talk. So I joined in 2008, beginning of 2008. It was under 100 engineers. And 2013, we're over 1,500. So there's a lot of rapid growth in our engineering team. And we faced a lot of problems. And a lot of the problems we solved by writing tools. So hopefully you'll get an overview of how we did that. So our main goal was to maintain that same efficiency as we grew. The same, pace of engineering. Like, you want engineers to feel just as productive, ship out just as much code. So our main challenges was trying to get the new engineers up to speed, keeping the development environment fast. So as more engineers are writing more code, everything kind of slows down. Engineers start to feel like they can't, code as fast. And then, of course, maintaining the quality of the application. In this case, the website or the mobile apps. So I want to kind of cover these three challenges piece by piece. So let's start with the new onboarding. So let's go back to 2008. Again, under 100 engineering employees, and we were hiring about 10 engineers a month. And this is kind of the middle of 2008 actually. And we spent a lot of time trying to get new engineers onboarded onto our Facebook, application stack, getting used to the coding technologies, getting used to working with teams and things like that, and getting used to the culture. So we invested a lot of time separately. So we used to have engineers paired up with mentors in their teams, trying to make sure they're coming up to speed, teaching them the new technologies and things like that. And what we found was engineers were spending a lot of time teaching other engineers to come up to speed. And everyone was kind of reinventing the wheel themselves over and over again. So, and this is about the time we exceeded Dunbar's number. Does anyone know what Dunbar's number stands for? Yeah. Okay. Anyway, so Dunbar's number is it's about 150, and it's for a human, it's that's how many social relationships you can have without like losing context. So after about 150 social relationships, you start to not care about the rest of the people. So well, this is your entire life. So at work, you probably only care about like 25, 30, maybe 50 people if you're really dedicated, right? And after that, you slowly stop caring about the other teams, you stop caring about what other people do, and that's when you lose touch, you lose sync, and people like don't know what anyone else at the company is working on. So our solution to it was boot camp. How many here have heard about our boot camp program? 2, 3, okay, 3 people. All right, so let me go through what our boot camp program is. So the goal of our bootcamp program is to bring new engineers up to speed, technically and culturally. This is very important because just technical isn't going to help us. And then, you know, we have multiple code bases. We want them to get a good experience on every single one. We don't want them to just know one thing, right? We want them to know what everyone else is working on as well. And one of the main perks about bootcamp is when you join Facebook, you're joining Facebook engineering, you're not joining a specific team. So in bootcamp, you actually get to pick what team you join. Either you like C++ programming and you like the newsfeed backend, you can go into newsfeed. If you like, you know, Android development, you can go into our Android, you know, newsfeed team, for example. So there's like a variety of teams you can pick from. And also, it's the easiest way for us to get our engineers writing code and committing as fast as possible. So day one in bootcamp, you set up, you know, you meet your mentor, you set up your development environment, you get your sandbox up and running, like your own version of Facebook, and you learn about the basics of Facebook's code base. And then you also get tasks from your mentor to start working. And that's kind of your first day. And you actually do one commit, like right on the first day in like a workshop class. And the commit pretty much looks like this. It's a first assignment. Like when it comes off, it starts off with just one friend, and you're just supposed to like query our list of friends API, get all the friends and display it. And this is what first assignment looks like for everyone. And everyone does this one assignment. So it's very easy to get used to our code base, and more importantly, our process. Because like every, you know, like you have to send it for code review, you have to get accepted. You have to know how to, you know, push it to our master repository. And all of these things for a new person to come in who's never had any industry experience is very important. And then you go through training on various topics. And what's important is we are doing this in a group setting, so you're getting support from other people who are starting off at the company as well. And we have classes set up to do this, so it goes through pretty quickly, and we're not wasting engineering time. And as the weeks go on, so boot camp is about a 6-week program usually, and from 2 to 4 weeks, in your 2nd to 4th week, you start branching out into the other areas. So like you start off in our web stack, which is the most common stack at Facebook, and then you go into your mobile stack. If you're a C++ developer, you would go into our C++ stack, or Java, etc. And you get to learn all these different things. And what we try to do as bootcamp mentors is to get new engineers to try all the different stacks, just so they get, you know, they have an idea of what's out there. And so far we've had about 1,400 engineers graduate bootcamp, and the feedback is amazing. Engineers join the engineering team ready to just, you know, start working right away. There's no ramp up time. There's, you know, they're already used to how Facebook works. And, you know, like it really helps like, get them used to the culture of Facebook. So that's boot camp. And I also wanted to, take this time to talk about our general engineering philosophy. Oops, wrong way. So we don't really have, like the 20% time that Google does. Instead, what we do is we have hackathons every 6 weeks, approximately. And these are where people come up with brand new product ideas and things like that. So the stat, I think, is 70% or 80% of all new products come from hackathon projects. So a lot of hackathon projects actually turn into new products, which is really cool. And this is the way we, kind of brainstorm into our next cycle of products. We also have a program called Hack-a-Month. So after you've been with the company for about a year to a year and a half, we encourage engineers to go work on a completely different team. So let's say you were a back-end programmer, we would urge you to go work on the Android app for a month, and it's think of it as like a month-long internship with a different team. And you have one small project that you go work on, and once you finish, either you can stay on that team or you get to come back. What this does is it kind of spreads the knowledge of our engineering code base. So like people in other areas know how you work, what your code looks like, what problems you're facing, and it also makes our general engineering workflows really like generalized, right? So we can say if you want to start off a new project, all these people are already experienced in this code stack, so we can just put them there. And also you get a really cool sweatshirt, which is important for engineers. In general, Facebook has really small teams, about 4 to 5 engineers. After that, we tend to break teams up and we divide up the project into multiple projects, so we don't really have more than 5 engineers on one team. We find that avoids dependencies and people stepping on each other's toes when they're coding. It's like, oh, I'm waiting for your check-in, so I'll go do something else until you're done. So all of that, and people, you'll feel if someone is falling behind or you know what's going on. And also, we iterate really quickly. And on the mobile teams, the one thing that we started out as having one big mobile core team for Facebook. So there would be Android core and iOS core. How many here are Android developers? And the rest are iOS, I'm guessing? Yeah? Okay. So we had 2 big mobile teams in engineering at Facebook. And then they couldn't keep up with the pace of features and products coming out. So what they ended up doing was creating a web view where all the products were essentially web pages loaded up inside our native apps, which didn't really work. So now the philosophy is we're going to have one Android core team that maintains the code base, that knows like Android inside out, but then we'll have smaller Android teams in each of the products. So like Newsfeed will have theirs, Timeline will have theirs, Places or Groups and all that. All these different product teams have their own Android teams. 2 to 3 engineers, not that big, and they prioritize their work based on their product, not on like what Android core thinks should be done. So this helped us kind of spread the knowledge. So I actually really wanted to pull up a graph. I didn't have time, but I wanted to show you the amount of authors inside each code base, like the Android code base or the iOS code base. It starts out with about 25, 30 before we started this program of like splitting up the teams, and then it just goes up to like 500. So really quickly, from 30 people committing to our iOS code base all the way up to 500. And this huge change really forces you to start thinking about how do we make this, how do we make this process faster? How do we onboard engineers onto iOS faster? So we actually have classes that any engineer in the company can take, which will teach you Objective-C, which will teach you like the Android, APIs and Android stack. So, you can. It's a week-long class. You just go take it, and it'll pretty much you're a mobile engineer at the end. So that was the mobile team. And then we also have a bunch of grassroots movement. So these are groups of engineers that get together and think of different ways to improve code quality, app quality, and things like that. And this is one of the examples. We always preach that red diffs are good. Red diffs is when you delete code and make like the code less in your code base. And if you delete more than 1,000 lines of code, like actual code, not CSS files or anything like that, but actual like logical code, you get inducted into the society of the Dead Code Society. And a t-shirt magically shows up on your desk, and you just don't know where it came from, but then you get added to this Facebook group, called the Dead Code Society, and you're part of this very like elite group. And this is all started by engineers. A lot of fun. I have one of these. No, it has to be code. Yeah, they're pretty particular. You have to nominate other people, so you can't just like randomly delete a library or something. You have to actually delete code. So the question was, what about refactoring? I think refactoring counts. So if you refactored and the code is 1,000 lines less, I will give you a shirt. All right, so that leads me on to my next topic, which is keeping development environment fast. Hopefully this XKCD cartoon is pretty familiar to you guys. Two guys sword fighting in the office, and the comment is, hey, get back to work. And the guy goes compiling, and then he says, okay, fair enough. This is what I'm trying to avoid, right? My entire team's existence depends on this not happening. So what do we do? So yeah, so I tried to look up the source for this. I couldn't find it. This is what my manager used to tell me. So if any developer, like any development task takes 5 seconds or longer, people will switch and either go browse Facebook or go do something else, check email or something else, right? And if anything takes more than 2 minutes, then they're going to leave their desk, they're going to go get a coffee, they're going to go chat with someone else. And this really slows engineers down. It's not only like bad for the company, but it's bad for the engineering morale, right? It like makes engineers feel unproductive. It makes engineers feel like their computers are slow or whatever. And so we try to avoid a lot of these. And this is kind of our metric, is like if something takes longer than 2 seconds, then maybe we should rethink on how to do it. So to kind of introduce you to Facebook's code base, every code line that gets committed has to be reviewed by another person in your team. We do not commit even like one line comment without a review. And we also work on multiple tasks at the same time. So if you're stuck on something, you can always create another local branch and work on something else. So you're never really working only on one thing where you could get potentially blocked. I usually have like 4 or 5 branches locally on my Git repository. And this is really only due to Git or Mercurial. Before we used to use SVN, and I actually had 3 SVN checkouts of our entire repository to do this. It's very annoying. Now it's much easier. And we have very small changes. So if you commit a diff for more than a couple hundred lines, people will yell at you. People will say, break this up into more logical, smaller diffs, and then you can commit it. And we also use we open source the tools we use. So if you haven't looked at it, fabricator.org, spelled with PH, is a really good set. I'm going to be showing you some screenshots from our code. from our tools, so you can take a look. Really good. So, website speed development, right? So the web server was not easy, but we did it. We created hip-hop for PHP. How many of you guys know what hip-hop for PHP is? All right, a few people here, the web developers. So hip-hop for PHP is taking PHP, translating to C++ and compiling it. And then we actually made it even better, and we created a virtual machine for hip-hop. That's what this logo is right here. And that interprets it. It has a just-in-time compiler, so it actually compiles the hot paths and things like that. So it's much faster, and it's a lot faster than the Apache implementation of PHP. So this is how we sped up our web development environment. For C++, we couldn't do much. We just built into CC cluster, so compiling on C++ is pretty fast. One good thing that my team did, I think a year and a half or 2 years ago, was change this CC to use our memcache cluster instead of disk. So memory is faster than disk, so all the disk CC objects are actually stored in memcache and not on disk, so it's a lot faster. So if and you'll download it over the network, and the network tends to be faster than disk also. So C++ compiling is a lot faster. For mobile, for Android actually, we open sourced a tool called Buck. Have people heard of Buck? Yeah, one person. That's it. Two. Okay. So 2 people heard of Buck. Buck is our Android build tool. And you might say, like, why another build system, right? The build systems out there didn't really fit our needs, so we built one. And the nice part is we open sourced it, and we're working with other companies. I think what happens is people leave Google, and they really like Google's build system called Blaze, and they miss it when they come to their new company, and they really want something very similar, so they start building one. And I've seen this happen many times over. Like Twitter has a build system called Pants, which is very similar to Buck, and we have Buck, and I think there's another, I don't remember if there's another system that started the same thing, but we're trying to collaborate, and hopefully one day Google will open source their stuff, but we'll see. So Buck is, why Buck? So for one, it gave us a 2x improvement over Ant. So the Ant works great for most people, but for us, Buck worked better. The second thing was it reduced incremental build times by a lot, especially when you turned on the daemon called buckd. So once you turned on the daemon, it could, build times went from seconds to microseconds. And then one thing about the way we store our application code is we store everything in one repository. And we like the build files to be in the exact same repository. We don't want a separate system for it. So when you make a change to the code base, you add a new module, whatever, you want to modify the build file right there. So it's an atomic change. It's just one change that goes through your build system. And Buck lets us do that. And we store all our applications in one repository and just have different build files to go through it all. And it works really well with IntelliJ. We mostly use IntelliJ internally, so that's what it works. And for iOS, we released a tool called XCTool, which is a command line tool for Xcode compiling and testing and things like that. Apple didn't really have one by default, so Fred Potter, one of the engineers from our mobile tools team, created this tool and open sourced it. All right, and the last topic I wanted to cover was maintaining the high quality. So at Facebook, we don't really have any QA engineers, any software development engineers and test. We don't have anyone writing tests, just purely writing tests. Our engineers are the ones that write the tests while they code. So if you write a piece of code, it's your responsibility to write the test that goes with it. and it goes along in the same commit and all these things. So we have tools that help us do this. And also, the way we test once it's committed is by using employees. Employees are our best test dummies. So employees get features usually 6 months before they actually get launched to the public. Employees use beta versions of the app. Of course, we have Raid Shake, which is app hands, and that we also have nags for updating. So pretty much every day I get a nag saying, update your app, is already out of date. And we have employees actually hit a different cluster of Facebook where we have better logging, better support for sampling of data. We can find out what's wrong quicker. So employees test. And we also do a lot of dog fooding. These are actually posters that were posted around our Menlo Park campus that asked people to switch to Android. Before, we were pretty iPhone-focused company. Everyone was kind of on the latest, greatest iPhones, and no one really used Android until we started, finding that we didn't have enough employees to test our Android app. So we did this, and actually our Android usage went up, and we actually now are pretty mixed. We have about half and half. Sure. So the question is, now everyone wants the latest and greatest Android phone, but what about the old Android phones? Do you still do the testing there? That is actually, I was actually discussing with the guys back there, that is our biggest problem too. Because no one wants to use old phones. Even like a phone like 4S, right? iPhone 4S, which is a pretty fast phone. It is still like iPhone 5 came out and everyone wants an iPhone 5. And not to mention feature phones. I think feature phones are probably, like our worst offenders, right? Because no one wants to use them. And we actually have old feature phones put throughout the office. Like they're just charging, and they have demo accounts on them, so people can walk up to them and use them just to play with them and see what it was like when they had a feature phone back then, and see how Facebook works on it. But yeah, and we haven't solved that one yet either. But we do have, actually I lied when I said there was no QA, because we do have QA only for feature phones. So we do feature phone testing, like there's quality engineers who go through and test all our feature phones. But it isn't really part of my team, so I kind of lie about it. All right, so now I wanted to talk about the actual tools that we use. So we have this tool called Sandcastle. I don't think anyone has heard about it, because I don't think we've given talks about Sandcastle. It's a couple years old, but what Sandcastle pretty much means is you have your dev server and you made a change on it, and now you want someone else to review that change. So what's the normal development process? They can, you send this to the code review tool, they can read the change in code, but they can't really see it. So how do we let other engineers see the same change you have? They can come and log into your sandbox and say, or come and look at your phone and say, okay, this is what the change looked like, good. I want to go read the code now. But it's not convenient. So what Sandcastle does is, you take your change, and this happens automatically. So when you send it to code review, it also does a git push to the Sandcastle master server, which sends all the same change to all its slaves. So now all the slaves have your change on it, and they make a build from it, and they run unit tests and other things, and they report it to the test DB. At the same time, now we have all these slaves with your change on it, so the reviewer or any other person looking at your change in the code review tool can also play around with it. So it's a better experience for a reviewer. We run every single test we have on that change. So every change at Facebook gets every single test run. And since we run it on a large set of machines, it goes by really fast. So here's a screenshot of trunk agent saying that there are 49 failures in this change that were not in trunk. So someone should really look at this before they commit, because this will break 49 tests. And so this is a screenshot that I took today of my fabricator panel. This is a change that someone sent to me. And one thing to notice is, here's the lint warnings that it gave me. There's like JavaScript lint and all these other things. Here are the test failures, the unit test, and we also do some performance testing. It's a tool called PerfLab. And here's the link to the Sandcastle. And what Sandcastle does is, like, once I click this, since this is a web change, I can click that and I can browse this tool as if I was on that developer's box. But that developer can actually, already be on the next branch, working on the next thing. They don't have to keep their developer box in that same state. They can keep moving, and Sandcastle is somewhere in the cloud. It has the change. Another nice part is we get test coverage. So if you see, here's the test coverage information. It tells you if it's red, it's not covered. Blue, it doesn't really matter. And it'll tell me which part of the change has coverage on using tests. And on the mobile, we just released this, I think like maybe 3 weeks ago, internally. So what this is Sandcastle for Android. We don't have one for iOS yet, but it's coming, hopefully. So what you do is you put in your change, your diff ID. It's just a number, if you want, or you can use it on trunk or master, and you select your emulator, which is this drop down right here, and then you click the go to emulator, and what pops up is a VNC view into an Android simulator. So it's not running on your laptop, it's running in the cloud somewhere, and actually works pretty well. So you can use it, you can launch the Facebook app and test out the change. So Sandcastle helps a lot. And the last thing I wanted to talk about is our release strategy. So first, we had, like on the web, our release strategy is pretty simple. We ship code twice a day, every day, or every weekday. And we cut a branch every week. So it's pretty regulated, but this does not work on mobile. It just fails. And that was another reason for us to do the web views, because we could iterate, we can get changes out faster. But what we realized is that just is not working out on the way we do mobile development. So what we started doing is time-based releases. And these are actually the messages we send engineers. I just copied and pasted. But the feature release really forces you to bake in time, where you bake the release in, make sure the quality is up to date, make sure like you're getting your bug fixes in from your employees and things like that before you ship it out to the general public, right? And so the releases should be no worse than what the last release was, right? So you don't want to get worse. And there's always, when the next one is going to come. So if you missed this release, there's always going to be a next one. So you know that the next release won't be delayed. And if your feature does not go in, you can catch the next one. And at the same time, you know that you won't be delayed by someone else's change. So like if someone else really needs to get this feature out, they could delay the release, but with the time-based releases, we just, it just cuts automatically and it's done. And this is essentially our release cycle. So it's 4 weeks of development on master, and after this, the next set of development weeks start, and then it's 3 to 5 weeks of stability testing. So this is where we make sure our 3.5 weeks of stability testing. This is where we make sure our release candidate is good, and this is what employees use, right? That's the line that employees use. And then at the end, we soak it for half a week where you pretty much can only get like really serious bug fixes in there. There's no more feature development going in. And then there's the release candidate, and then we send that to, and then we cut the release candidate and we send it to the, either the App Store or the Google Play Store. Great. And now I want to talk about what we're working on next. We're actually working on end-to-end testing for native apps. So my team in London is actually doing this right now. So for iOS, we're using iOS driver, and the Android one is the more interesting one. So I hope, hopefully sometime soon, maybe in the upcoming months, we'll be able to open source our Android end-to-end testing system. So think of it as WebDriver for Android. You write Java code for testing, and it will run it against a simulator, go through, click the buttons you need to, scroll where you need to, and things like that. And it will work alongside Buck. So Buck runs our Android end-to-end testing system. And we're working on smoothing out, our developer workflow even more as we get more mobile engineers into the system. We always keep working on it. And the last thing we want to do is see if Buck will work for iOS and other, other build projects.